Now this is, as I think I've said before, this is one of the most useful sections in the class because this is the sort of thing you need to know to keep the credit card companies from eating you up. All right, we start off with compound interest. Starting with a present value P, it grows at a compound interest for the interest rate of I for n periods, I per period for n periods. The future value would be P times 1 plus I to the nth power. Okay. Future value. Now, going backwards to calculate P by dividing out and get P equals future value times 1 plus I to the negative nth power. That's the present value of a future value of n given n periods at interest rate I between now and then. Now, here's a concept you might find useful someday. An annuity. An annuity is a sum of money. You pay regular payments, equal payments R into an account. It grows at a rate of I per period for n periods, resulting in a future value of A sub future. The idea is that here's a bank account and you're putting money into it and that makes it grow. But in addition, it's growing by compound interest and that makes it grow even faster. So you have both compound interest and your own savings adding up to a future value. And what is that future value? All right, so for example, here's $400 being paid regularly and a 0.04 interest rate per period and for 20 periods. Then AF is a sum from 400 is the last payment, 400 times 1.04 for the next to the last because it went through a compound interest period. 400 times 0.04 to the second power for the second to the last because it went through 2 compound interest periods, and so on all the way up to 400 times 1.04 to the 19th. 19th because this is 20 periods, but it's 0th power here, so 20 minus 1's power here, 1.04 to the 19th. Okay, now we can rewrite this as 400 times this geometric series. 1 plus 0.04 plus 0.04 squared all the way up to 0.04 to the 19th power. Okay, this geometric series would be 1 minus 0.04 to the 20th power. We add 1 here over 1 minus 1.04. And after a bit of calculation, it's $11,911.23. Let's see, 400 times 20 periods would be about 8,000. So this 11,911 is $3,911 more than just the accumulation of your deposits. It's also due to compound interest. So here, compound interest is your friend. Okay, if you pay R n times an interest rate per period I, then the final amount will be R plus R times 1 plus I for the next to last payment, for R times 1 plus I squared to the second from last, all the way up to R times 1 plus I to the n minus 1 for the first. Okay, you pull out a factor of R times 1 plus 1 plus I plus 1 plus I squared, all the way up to 1 plus I to the n minus 1. This is a geometric series. It'll be 1 minus 1 plus I to the nth power instead of n plus minus 1 over 1 minus 1 plus I. And it's to be R times 1 minus I to the n over negative I because of the minus. This minus makes you reverse these. So the future value of an annuity will be R, the irregular interest, times 1 plus I to the nth minus 1 over I. That's the future value. Now, here's something that I've grown familiar with over the years, and I'm hoping that you will too. A mortgage. The mortgage is kind of a reverse annuity. The idea is you pay into an annuity in exchange for something worth the annuity's present value. So I'm paying into an annuity called a mortgage, and a while back I promised that payment in exchange for the use of the house that I live in now. Now, okay, the thing is that you agree to a present value. So the present value of the annuity will be the future value, and then we have to multiply 1 plus I to the negative nth power, the discounting factor, which is what we had before. Present value is future value times 1 plus I to the negative n. This 1 plus I to the negative n is the discounting value. factor. So we combine this for the future value with this for the present value. So the present value is 1 plus I to the negative n times, well, the future value R, regular payments, times 1 plus I to the n minus 1 over I. Okay, this multiplying into this, things simplify out. Here we go. The present value of an annuity is the payment, the regular payment, times 1 minus 1 plus I to the negative n over I. That's its present value. Now, on the other hand, if usually it's not that you just sort of start blindly throwing in money and hope you can get you can buy at present something for a set value. Usually it's the other way around. You're given the set value, you're given the interest payments, given the number of payments. How much must you pay per term? Well, you get from here, we isolate R by multiplying both sides by the reciprocal of this. And so you get the regular payment equals the present value times I over 1 minus 1 plus I to the negative n. This is the installment payments for an amortization. Amortization, by the way, that word amortization, like the word mortgage, has the word mort in it, meaning death. We're going to kill that debt. You buy a house, you have this horrible monster of a debt over you. Once a month, you feed the beast with a small amount of money, and that makes it a little bit smaller than it was the previous month. Unfortunately, in the case of a mortgage, compound interest is not your friend. It makes the debt tend to expand between payments. Okay. What is the future value of an annuity of 20 annual payments of $5,000 each into account with annual interest of 12%? Regular payment is 5,000. Interest rate is 0.12 and equals 20. So the future value is R times 1 plus I to the n minus 1 over I. So that'll be 5,000 times 1.12 to the 20th minus 1 over 0.12. And after a little bit of work, the future value is $360,262.21. But frankly, I think that when you bring it down to cents, that's probably a little more accurate than need be. Okay, what's the present value of an annuity with 20 semi-annual payments, 1,000 each for an account of 9% per year, compounded semi-annually? Okay, the regular payment is 1,000. The semi-annual payment is 9% over 2, 0.045, 20 such payments. So the present value is R times 1 minus 1 plus I to the negative n over I. So that's R is 1,000. 1 minus 1 plus I is 1.045 to the negative n is negative 20 or 0.045. And this, after a bit of calculation, is $13,007.94. That's the present value of the annuity. Let's see now. Present value, but you've paid 20,000, 20 payments of 1,000 each. So you paid with 1,000. You're getting a present value of 13,000. So basically, the remaining 7,000 is basically paying for compound interest payments. Like I said, in the case of a mortgage, compound interest is not your friend. Here's a $12,000 car. That'll be the present value you want to put up. It's paid in monthly installments, 12 times per year, over 4 years. So 12 times 4 makes 48 payments. On count with 10.5% annual interest. But so the monthly payment is interest is 0.105, 10.5% over 12, which is 0.00875. What are the monthly payments? Okay, regular payments is the present value times I over 1 minus 1 plus I to the negative n. AP, the present value is 12,000. We put that there. I, we worked it out as 0.00875 here. Over 1 minus 1 plus I, 1.00875 to the negative n, that's negative 48. Here this is. And churn, out comes $307.24. It's $307 per month paid over 48 payments. 4 years, 12 times a year. So times 4 times 12 makes total of $14,747 paid out for a $12,000 car. So that's $2,747 paid for interest service. So that $2,747 is a finance charge for the privilege of owning the car now rather than in the future. Here we are asked for the monthly payment for a 30-year mortgage of a $300,000 house. Oh, I wish I could get them for that cheap. At 4% per year, I wish I could get it that. Oh, no, actually, I did get it at that interest rate. Compounded monthly. What is the total amount paid on this mortgage over 30 years? How much is the finance charge? Okay, the present value is $300,000. The number of payments is 30 years times 12 months a year is 360 payments. The interest rate per payment is 4% divided by 12. Okay, so the regular payment is AP 300,000 times I 0.04 over 12 over 1 minus 1 plus I 1 plus 0.04 over 12 to the negative n is negative 360. So here this is, and churn. Out comes the number 1432.25. So that's $1,432.25 for monthly payment. All right, now that times 360 payments, 12 payments a year over 30 years, comes out to $550,608.52 in total. Now, this is to pay for $300,000 house, means the finance charge is $215,608, almost as much as the value of the house, value of the house itself. Once before I got this house, my wife and I went down to the bank, and I had this formula already programmed into my calculator, and the lady at the bank would say, "Well, how about this much off and this?" So I go tick 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 tick. Oh, this is how much you want me to pay a month. Okay, she said. How about this much off and this interest rate? Tick 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 tick. Oh, you mean then I'd be paying that much per month, and so on and so forth. We went back and forth. She was somewhat nonplussed by the fact that I could turn her figures into figures that made sense for me. I mean, what she wanted to know was interest rate and points off and this. I wanted to know how much I had to pay a month. She was not saying that directly. I had to figure it out specifically. Eventually, she got so flustered that she said, "How about an interest-only loan?" Which, of course, would mean that I'd be paying it forever. And I said to her, "You sound like a credit card company." It was mean of me, but she was trying to play a low trick just then. Anyhow, so this is sort of thing you really ought to know about, and so here I tell you about it, and you'll have some examples of working it in the book, and so there we are. Okay, I think that's it for now. We have concluded our 2 sections for today, excuse me. I open the floor to questions, comments, requests, and suggestions. Very well then. Motion to adjourn. Is it seconded?
Second.
It is seconded. I shall see you on Wednesday. And soon I shall be opening up Vinyl and other things on the website. And a good morning to you all. Villegas. Questions, requests? If you have no questions, I shall be shutting down in 30 seconds.